Atoms of elements complete their octet or duplet state in three ways. They can either lose their electrons, they can gain electrons, or they can share electrons. Compounds formed by gaining and losing electrons are called ionic compounds, whereas compounds formed by sharing electrons are called covalent compounds. Let us see each type of compounds in some details. First, let us see what are ionic compounds. For that, let us consider elements in which one element is electron loser and other element is electron gainer. Let us consider sodium having electronic configuration 281. Let us draw only the outermost shell electrons in sodium. In outermost shell, sodium has only one electron. Let us draw that electron with a cross. Now let us consider chlorine atom with electronic configuration 287. Let us draw electrons in the outermost shell. In outermost shell, chlorine has 7 electrons. So let us draw these electrons with the help of dots. Now both sodium and chlorine want to achieve the octet state. Sodium will tend to lose one electron and chlorine will tend to gain one electron. So chlorine can give this electron, sodium can give this electron to chlorine so that it completes its octet state. Hence, sodium will become a positively charged ion having a unit positive charge on it, and chlorine will become a negatively charged ion with a unit negative charge on it, having 8 electrons in its outermost orbit. Hence, the compound called sodium chloride will be formed. Compound called sodium chloride will be formed, in which both sodium and chlorine will achieve the stable octet state. Now let us consider another case in which sodium wants to react with oxygen. Sodium has one electron in its outermost shell. Oxygen has 6 electrons in its outermost shell. Both these atoms want to attain the stable state by having 8 electrons in their outermost shell. Now when these two atoms come close to each other, the sodium can offer its only electron to oxygen, but oxygen requires one more electron to attain the stable state. So in that case, another sodium atom can come into picture with its one electron. So this sodium atom can also give this one electron to the oxygen atom so that both the sodium atoms complete their octet state. Also, oxygen atom has 8 electrons in the outermost shell, so it also completes its octet state. So the compound formed will have a formula Na2O with 2 sodium atoms and 1 oxygen atom. Now both these sodium atoms will carry a unit positive charge on them because they have lost 1 electron each, whereas the oxygen will carry 2 minus charge on them as it has gained 2 extra electrons. So the molecular formula of sodium oxide will be Na2O. Now let us consider another case in which aluminium atom comes into contact with a chlorine atom. Aluminium has 3 electrons in its outermost shell and it wants to lose these 3 electrons to attain stability, whereas chlorine atom has 7 electrons in its outermost shell and it wants to gain 1 electron to attain the stable state. Now this aluminium can give 1 electron to this chlorine, but aluminium has 2 more electrons to lose. So 2 more chlorine atoms can come into picture, and each chlorine atom will require 1 electron to attain the stable state. So the aluminium atom will give 1 electron each to 3 of these chlorine atoms, and hence it will lose all the atoms in its outermost shell, and also each chlorine atom will attain the stable state by accepting these 3 electrons, and the formula of the newly formed compound will be AlCl3 with 1 aluminium atom and 3 chlorine atoms. The aluminium atom will be actually aluminium ion having a charge 3 plus because it has lost its 3 outermost shell electrons, whereas chlorine atom, each chlorine atom will carry a unit negative charge as each atom has gained 1 extra electron. So the chemical formula of the compound will be AlCl3. Now let us consider one example where aluminium and oxygen atoms come into contact with each other. We know that aluminium has 3 electrons in its outermost shell, whereas oxygen has 6 electrons in its outermost shell. Now this aluminium atom can give 2 of its electrons to oxygen atom so that it completes its octet state, but this third electron cannot be accepted by oxygen. In that case, one more aluminum atom can come into picture with 3 electrons to be given away and 2 oxygen atoms with 2 electrons each can be accepted. For example, this third electron will be given to this oxygen atom. This aluminum atom will give its 1 electron here, and rest of the 2 electrons will be given to these 2 places, the last oxygen atom. Hence each oxygen atom will gain 2 electrons each and attain the stable state. Also the aluminum atoms, 2 aluminum atoms will also gain the stable state by losing 3 electrons each, and the chemical formula of the newly formed compound will be Al2O3, in which each aluminum atom will carry a charge of 3 plus because it has lost 3 electrons each, and oxygen will carry a charge of 2 minus because each oxygen atom has gained 2 electrons. Now this formula can be found out by the valencies also. We know that aluminium has a valency 3 and oxygen has valency 2. So if you write this 2 here and this 3 here, then the formula becomes Al2O3. So by exchanging the valencies, by crossing these valencies, we can also form the same formula that we have found using the electron give and take. Let us try to find one more formula in which magnesium tries to react with oxygen. Let us see what happens when magnesium reacts with oxygen. We know magnesium has 2 electrons in its outermost shell, having electronic configuration 2s2, where oxygen has 6 electrons in the outermost shell. It requires 2 more electrons. So this magnesium can give the 2 electrons to the oxygen so that both of them achieve a stable state. So magnesium loses its 2 electrons and oxygen gains those 2 electrons, and hence the molecule form is magnesium oxide, in which magnesium carries 2 plus charge and oxygen carries 2 minus charge. Now this formula can also be written using their valencies. We know that magnesium has valency 2 and oxygen has also valency 2. But here only crossing will not do the job. We cannot write this formula as Mg2O2 because only one magnesium atom can react with only one oxygen atom to form MgO. So this 2 has a common factor, and that is 2. So we have to remove that common factor and write the formula as MgO. So this is how we can write chemical formulae of compounds if we know their electronic configurations or their valencies.